Hey there! So we have our data loaded to Data Lake in Azure, and now it's time to finally start transforming it. And actually, in bigger companies, it might be your only task as a data engineer, because simply other areas like data ingestion or data modeling might be handled by different teams. So let's start doing some transformations. So let's get started. Alright, so data transformations. And today we will work on this Rebrickable JSON file that we ingested some time ago from Rebrickable API using Data Factory. And today I would like to show you some common transformations, common data transformations that happen in many projects. Obviously, I won't be able to show you every possible transformation out there. It's simply not possible, but I will try to focus on those commonly used ones. Alright, so let me start with showing you how our data looks like currently. So let me open Visual Studio Code with our minifix.json file loaded. And as you can see, it is a JSON file. Great. APIs, they pretty often return data as JSON, and that's fine. But for our needs, it doesn't look that great. Simply because JSON file, by its nature, it's quite often a nested file. I mean, it contains complex data types, complex structures. Like here, you can see this results element is an array inside this JSON file. And basically, it's an array of objects. So each of those JSONs that I've just highlighted is a separate data about a minifig. And actually, that's the part that we care about here. So what I would like to end up this episode with is to have a nice tabular data about those minifigs instead of JSON. So what do I mean by this? Well, we'll grab all of those fields, extract them from those arrays, from those JSON objects, and simply make them irregular columns available instantly at the, let's call it, root level of our table. That's one thing. Secondly, you might see here some technical columns that were pretty important for the data ingestion part, but right now we don't need them anymore. So I would like to get rid of them. Then, if you take a look at column names, well, maybe I don't like them. I would like to make them more user-friendly. Or maybe I would like to rename them to follow our company standards. So for sure, that's something that I will be taking care of. And what else? Probably data types. I am not sure what data types will be used for those various columns, but for sure I will want to check them. And if you have a date, like this last modified date time, I would like to treat it as a date. If we have a number, like this number of parts, I would like to treat it as a number, and so on. Then, if we have some NULLs, probably I would like to do something with them. Also, I would like to apply some business logic here, just to simulate adding some additional transformations. And finally, let's assume that our dataset contains duplicates. Pretty common case. And we'll have to do something with it. So that's the scenario for today. And today I will be doing all of this stuff using Azure Databricks, my favorite tool in Azure to do transformations. And today I will do most of those transformations using SQL, because for me it's my preferred language. But please remember that in Databricks, well, you could use any of those languages, Python, SQL, Scala, or R. So it's up to you. And actually, some of those transformations, some of the steps, I will do using Python. So let's get started with doing the common transformations on our JSON file. And now, my data, it is available in my tabular Delta Lake storage account. It's a data lake. So first of all, we've got to connect to it somehow. And that's the stuff that we covered in the previous episode. So I will just paste the code that will help us to connect to a data lake. So that's the configuration part. And basically, I am connecting to a data lake using a service principal that is granted proper permissions. And the secret that is used to authenticate as a service principal is retrieved from Azure Key Vault. So it is a nice and secure approach. Great. So let me verify that the connectivity works by using this dbutils fsls command that will go to my raw container in my data lake and just try to show the contents of this container. And yep, it works. So it means that from networking point of view, from the connectivity and security point of view, everything looks fine. All right, so let's load our JSON file to a data frame. And again, that's something that we did in the past. So I will just paste the code. And let me tell you what it does. Well, simply, I'm loading a file from my data lake, basically a file, this minifix.json file. I'm telling Databricks that it uses a JSON format, and the output I want to be available in data frame called df. Very common name for data frames. All right, so let's run it. And it has been loaded. So actually, let's take a look inside this data frame to see if it really contains our data. And I will use this display command to achieve this. And yes, it works. So you can see that indeed we've got these three technical columns, count, next, and previous. And then we've got our results array. You can see that it is really an array. So let me expand it a bit, like so. And then each of those things is a separate object, or how it is called here, it is a separate struct. So here it is treated as an array of structs, but you can think of it like an array of objects. And then each of those objects, well, it contains our actual data, the stuff that we care about, the stuff that we'll retrieve as a regular column. And actually, if we go back a little bit, I can display a schema of my data frame. And indeed, this results is an array, and it is an array of structs. So our JSON file was properly read and parsed. Great, but we know that we'll have to do something with this array because I don't want to have this complex type in my data. I want to have good old plain columns. But before we go to handling this array, let me just check how many rows we have in our data frame. And to achieve this, I will use count function. And we've got 142 rows. And basically, if we go back to our data, let me show it to you. So we've got 142 of such rows. And basically, each of the rows, it corresponds to a single data page that was read from the API. You can see those URLs to the previous and next pages. And within each row, we've got many minifix, like 100 or so. So that's the stuff that we'll have to handle. All right. So how to flatten our array into nice columns. And if you Google it, then sooner or later you will come up with this explode function that is used to flatten our arrays. And let me show you how it looks like, how it works. So let me add a new cell, and I'm still doing all of this stuff in Python. We'll switch to SQL in a second. And basically, to be able to use this explode function, I will have to import it to my notebook. And to do this, I will just use this import syntax. I'm telling Databricks, hey, I want to import this explode function that is available in PySpark SQL functions. Pretty common stuff. And then I will write a code that will make use of this explode function. So let me just copy it. And let me explain what I want to achieve here. So I'm creating a new data frame called df2, and it will contain a result of a data frame, our df, to which I'm applying a function or method with column. And this with column method is used simply to add a new column to our data frame. This new column will be called exploded array, and its value will be set to the results of the explode function, the one that we've just imported. And I will paste to this, I will pass our array, this results, it's a name of our column from data frame df that contains our array. So to show you, so this is the column that we want to explode. And this explode function will work in a way that it will take a look at our array, and it will grab all of those objects and make a separate row from each of them. So it will simply, well, explode our array into separate objects. And now all of those columns that are shared by those all objects, well, they will be simply duplicated. So let me show you what will be the result of this command. So let me explode this array. So we still have our technical columns because we didn't do anything with them yet. We still have our array. That's fine for now. And what has changed is that we've got this new exploded array column, which is a struct. So it is no longer an array like the results column. And take a look that inside we've got only a single object in every row. So instead of this array with multiple objects, each of the objects from the array was put into a separate row. So we are making some progress here. And as I said, those three columns that were not part of the array, well, they are simply duplicated. And that's fine. So that's how we can flatten the array, or how we can explode it. And actually, the remaining transformations I will do using SQL, my language of choice. If you prefer, you could try to do the same using Python. It's completely doable. If you don't know how to convert one command from one language to another, you can ask Assistant, which is here, and you could write a query like, please rewrite this to Python, or please rewrite it to SQL. And it should give you some answer, maybe worse or better, but at least it should give you a hint how to get started with rewriting the command in another language. All right, so I would like to work on this data frame tool that contains exploded array in SQL. And to make this data available in SQL, well, you already know what we have to do, right? So I will use this replace or create or replace temp view command on my data frame tool, which will create a view called my data that will be available from my SQL queries. So let's do this. and it's done. All right, so from now on, I will switch to SQL. So let me switch from Python to SQL, and it results in this %SQL magic command that tells Databricks, hey, this cell should be run as SQL. And here I will just run regular commands. And let's start with checking how many rows we have in our My Data view, which simply means in our exploded data frame. So I will use count function from SQL from my data, like so. And take a look that we've got over 14,000 rows, way more than we had previously in the original JSON file. Why? Because we exploded it. We grabbed every object from the array and we put it into a separate row. And if you're paying attention, this number 14,144, it should look familiar. And yes, because we already saw this value somewhere. So basically, in our JSON file, JSON response we got from the Rebrickable API, well, it contains this count field that tells us how many minifigs are there in total. So we can see that those two values match. So probably we did a good job with extracting all of those objects into separate rows. So in this case, this count column could be used for validation purposes. All right, great, but if we take a look at our data from SQL point of view, well, it doesn't look correct yet, because this exploded array, it is still an object. We don't have those fields available as separate columns. So what I would like to do right now is to grab each of those object properties or object fields and make them a regular column, like so. So how to do this? And well, that's pretty simple. So I will just reuse our cell. And to do this, we've got to use a special syntax. So we'll start with the name of the column that contains our objects. In this case, it is exploded array. So select exploded array, then simply dot, and let's provide a name of the field that you would like to get, like last modified dt. And we can repeat the same stuff for remaining columns. So let me just copy this and let's run this command and let's see what happens. And take a look. We simply just added additional 6 columns like this: last modified dt, name, number of parts, and so on. And now there are just regular columns. It is no longer this data stored in an array of objects. No, it's a good old plain column. Exactly what we wanted to achieve. And take a look how easy it was to extract this data from an array and convert it to just a regular column. All right, but if we take a look at our data, you will see that it still contains those fields, those columns that we don't really want to have, because at this moment we don't need them and we would like to just get rid of them. And again, in the case of SQL queries, it's super simple. We just have to, well, exclude them from our query. So previously I had this star in my query, which simply means just grab all columns. And if I remove this, it will just return only those columns that were explicitly mentioned So only those 6 columns. And let me run this to prove that it really works. And yet, this time we have only those 6 columns. So it was so simple to get rid of those columns that we no longer need. All right, so our dataset is starting to look really nice, but still I am not fully satisfied with this, with the way it looks. Take a look at those column names. Well, it uses this strange naming convention, and I would like to make those names more user-friendly. So business users, if they are granted access to this data, they will know what those columns mean. So I would like to rename our columns. And again, in the case of SQL, super simple. So let me revisit our query. And I will simply add this as statement and then provide a name that should be used for this particular column, like last modified date time. Then as name, as number of parts, as image URL, as set number, as set URL, or whatever names you would like to choose. And let me run this query. And now take a look, the column names changed. So we no longer have those original names that were available in the JSON file. No, we simply renamed them to better match our standards. So with every transformation, with every step we do, our data is starting to look better and better. All right, but let's take a look at the schema of our data. And especially here, this last modified date time, well, it is stored as a string, as a text. And below, we can see that actually it is a timestamp. It's a date with a time portion. So for sure, I would like to treat it as a date or date time, not as a text. And you might ask why. And simply, if we treat it as a date, then we'll be able to compare various dates, calculate differences between them, and decide which one was earlier and which one is the newest one. We will be able to calculate or to add a specific set of days to this date to produce a new date. So that's what we want to do. That's what we want to have. So for sure, I don't want to compare two dates using alphabetical comparison. No, I want to compare them as dates. So if you have a date in your dataset, make sure to convert it to date or timestamp or date time, however you want to call it. And similarly, with this number of parts column that is stored as a long type. And here we can see that actually this column, well, it contains very small values, small numbers. So maybe storing it as a long, which uses 8 bytes, is not necessary. Maybe I would like to convert it to integer, which will use only 4 bytes, so we will save on memory. So for sure, some data types conversion is needed here. Remaining stuff, yes, I can leave them as strings, as text. That's fine. All right, so let's revisit our query and let's start modifying those data types. And I will leave this last modified date time as it is, so we'll be able to compare the values. I will just rename it like original. Then let's say that I would like to keep only a date part, so year, month, a date without time portion. And I could use a build toDate function that expects the value you want to convert to a date. In our case, it is last modified dt. And let's give this column a name, like last modified modified date. Great, but maybe also I would like to have a date with a time portion. So maybe this hour and minutes part, maybe it is important to me. So again, it's possible. I would use toTimestamp function and take a look how many options, how many functions we have that can convert values to time in a different way, using different logic. So if you're interested, take a look at it and see what those functions do. Here, I would use just the simplest version. So let me copy the value and let's give it a name like as last modified date time. Great. And the last thing we want to do is this number of parts. We want to convert it to integer. And here I would use this universal cast function that allows us to cast some value from one type to another type. And I will do this like this: cast my column as integer. And maybe let's give it a name. Oh, maybe not. And that should be it. So let me execute this command and take a look what has changed. So we've got those new columns of date and timestamp data types, and you can see the values below. So this date, well, it contains only a date part. We've got the same value as a timestamp, date with a time, and you can also distinguish it by looking at the icon, different icons compared to a string. And for this number of parts column, it is stored as an integer, no longer as a long value. All right, so at this moment, our data set, it is looking really good. It's a really nice table that we could work on to add some additional logic to it. So let's say that one of the business requirements we got about this data set is to add a new column here. And this column, it will store a type of our minifig. And we got the rules that this new column, it will be based on the name column. So basically, if the name column contains a toy value, then our minifig type should be set to a value of toy. If the name contains droid, then the value of our new column should be set to droid, and so on. And if none of those conditions are met, then we should set the type to other or unknown. It doesn't really matter. So how can we do this? And again, we will revisit our query that we've been using so far. And here I will use a case statement that allows us to introduce a conditional logic. And in general, it looks as follows. So case, then we'll provide various conditions, then end, and let us give a name of this column. And let's call it minifig type. And then what do we provide inside this case statement? Well, simply we can use here multiple conditions like when something, then something. And we can have multiple of those conditions. They will be evaluated from the top, and the first condition that is met will stop evaluating remaining conditions. And we also can have this catch-all value. So if none of those defined conditions are met, then we will use the value defined in the else part. All right, so let's do this. So in our case, we want to base the value of the minifig type on the value of our name column. So let me grab this part and let's use it like this. So when our name column contains a toy phrase, and in SQL it can be written using like statement, like toy, and to make sure that this toy can be found anywhere within this name, I will use this strange syntax of %toy%. That's how it is written in SQL. Then something. And basically, this phrase means if toy phrase is found as anywhere within the name value, then it will evaluate to true, and as a result, this statement will be used. Then I want to set the value of our minifig type to toy, like so. So let me repeat this for Droid, because that was our requirement. Let me remove this one, because we don't need this. And else, if it is neither a toy nor Droid, then I would like to call it other, like so. So let me execute this statement. And you can see that indeed we have this new minifig type column that for the first row was set to toy because our name contains this toy phrase. For the second row, it has other because this customer kit name, well, it doesn't have neither toy nor Droid values. For the third row, we've got Droid because Droid was found in the name, and so on and so on. You could make this case statement case insensitive. So at this moment, this phrase, it is looking for this toy statement written in this way with capital T and then lowercase o and y. So if I do this like this, if I use uppercase, take a look, this condition is not met, even though this toy phrase is found here. And maybe in some other row, we've got this toy written in this way. Or maybe someone made a mistake and used this phrase, this way of writing this. Or like that, like so. We don't know. So if you would like to make this statement case insensitive, a common method is to simply uppercase this statement, so to make capital letters, and then here also write the condition using capital letters. So this time it is again evaluated to true. So that's how you can handle those case sensitivity or insensitivity. But for now I will just remove this just to not confuse you too much. Alright, so that's how we were able to add this new column with some conditional logic. Great, so our data, our result set is looking really good. So let's try to handle duplicates. Because in real life, pretty often you will encounter duplicated data. Now, in this case, this rebrickable data has a really good quality, so there are no duplicates. So what I did was to create a new file in my rebrickable directory called minifigs copy. That is much smaller than the original one, and I added there 3 minifigs that are more or less duplicated versions of some existing minifigs, just to introduce some bad data to our dataset. Because I would like to show you various ways we can use to handle duplicated data. Alright, so let me load all of those files into a data frame. So I will use Python commands and take a look that here I'm using this star.json syntax just to load all files that are available in this minifigs directory on my Rebrickable directory. So this time 2 files will be loaded. Then I am exploding the array and I'm making this result available in SQL queries as my duplicates view. So let me execute this and let's switch to SQL to verify what we have right now. So let me switch to SQL and then let's write some query. Select count from my duplicates. And we should have three rows more than previously because the second file it contains 3 additional minifigs. And yep, we've got those 3 additional minifigs that we'll have to find and do something with them. Alright, so how to handle duplicates? And it depends what actually you want to do. So let me display the data that we have right now in our table. It is still not cleaned, but that's fine. We'll do this in a second. And let's say that I would like to grab only unique values of my set number, because this column, this field, it looks like a primary key for this dataset, identifier of every minifig. So to get this value would be like this: exploded array.setNum. We did it like half an hour ago. So these are all the identifiers of our minifigs. Great. So let me count them. How many of those we have? We've got 14,147 rows with those identifier. Great. But how many unique values do you have? So let me simply add distinct phrase to tell Databricks, please ignore duplicates. And right now, you will see that we've got 3 values less. So which means that we've got 3 rows. We've duplicated this set number. All right. So what should we do if you would like to get only unique values? Simply use distinct phrase like so, and it will ignore duplicates. And you can have a list of files, a list of columns like so. So it will now return a unique combination of set number and a name, and so on and so on. So that's how easy we can get rid of duplicates. All right, but actually, in many cases, we want to do something more with those duplicates. We want to analyze them, show them to business, and tell them, hey, this is your data that you claimed that it is great, it is perfect, it is pristine, but actually you have duplicates. And maybe you are even not aware of this fact. So help me decide what to do with this. But to be able to start this discussion, we have to know exactly what data is duplicated, how it looks like. So let's try to find those duplicates. And we know that for sure there are some rows, actually 3 rows, that have duplicated this setNum value. So how to find them? Well, simply, let's group our data by this column, by this set number. Let's calculate how many rows we've got them for each of those set numbers, and let's sort them to see which ones are repeated. So let me group the results set by our set number, and let me order the results by the number of occurrences descending. So we'll have those duplicates at the top. And yes, we can see that for figure 1, 3, and 2, for each of them, we've got 2 rows. And that's correct because I've added duplicates for those three identifiers. All right, so let's actually try to find those duplicates inside our data. And actually, let's modify our query a bit to ignore all those rows for which there is no duplicate. And again, in SQL, that's super easy. You've got to add this having clause that will operate on the aggregated data. And I will add a condition that we should include only those rows for which number of those rows with a specific value of set num is bigger than 1. Namely, it will return only our duplicated data. So only those three identifiers. Great. But again, I would like to see exactly those rows, not only identifiers. So how to do this? Well, let's grab our wonderful query that we've done so far, and let's modify a bit. Obviously, we've got to use my duplicates as a source. And here, instead of returning all data, I would like to restrict the results to only those rows that have set number set for one of those three values. And obviously I could hard code those values in the query, but in general, that's not a good practice. Imagine that you've got 100 of duplicates and you really don't want to type them manually in your query. Instead, let's use a dynamic approach. So let's add a where condition to restrict the results to only those rows for which this set number is in the values returned by our previous query. So let me copy this query and let me paste it here. Let's format it a bit just to make it look a little bit nicer. And we don't need all of this stuff. Basically, we don't need the can't field, and it should be fine. And at the end, I would like to order the result set by our identifier, so it will be easier to compare the data. And hopefully it will work just fine. And yep, we got only those 6 rows. Why 6? Because these are the rows that have duplicates. And if I scroll to the right, you will see that actually this is our duplicated identifier. I am treating this set number column as an identifier of this dataset. So this fig 0001, I know it identifies uniquely a specific row, a specific minifig. And you can see that for value fig 01, we've got 2 rows, which is bad. Likewise, for fig 02, we also have 2 rows, and for fig 03, we also have 2 rows. And those duplicates were added by me explicitly in this second file. So that's expected, actually. So let's visually compare those rows, those pairs, to see what I've done there. So basically, I've modified a name for each of those pairs. So for the first minifig, I added this v2, and I also changed the last modified date time to 2021, just to simulate that it was really a change made in the source system. Then for the second minifig, I added this super part to the name, and also I changed this last modified date time. And finally, for the third minifig, what I did was to add this at and ping part of the name. And I also changed a last modified date. All right, So with this data, we could go to the business, show them, hey, your data contains duplicates. How do you want us to handle it? And in this case, because we have this last modified date time column, which probably indicates the time when this particular row was updated in the source, they would give us a solution like this. Please just take the latest version of a given row and ignore all previous ones. So you can compare it to slowly changing dimension type 1. So it means that in our case, for the first minifig, we should use this version because it is newer. For the second minifig, we should use this one because again, it is newer, 2023 versus 2020. And for the third minifig, we should use this value because it is a newer version. All right, but how to handle this? How to write a query that will be able to find those duplicates and eliminate them? For sure, I don't want to do this manually. No, I want to have a query that will be able to process any number of duplicates. And that's where window functions will come into the play. They are super useful in SQL. And if it is the first time you hear this window function concept, then I strongly recommend to read this book, TSQL Window Functions by Itzik Ben-Gan. Itzik knows a lot about the databases, and this book is great. It will show you multiple use cases when window functions can be used. And you will be surprised how many business cases can be solved with window functions using beautiful solutions. And I know this book was written with TSQL, Transact SQL in mind, which is used by Microsoft SQL databases. But the concepts described here in this book are quite universal. So if you would like to learn more about window functions, take a look at this book. And for this exercise, I will use a row number function. So let me explain how it works and what it does. So let me switch to whiteboard and let me draw something. All right. So let's assume, row number. That's one of the most commonly used window functions. So let's assume that we have the following dataset. And for simplicity, let's assume that it contains only two columns, some kind of an identifier and a date. And let's say that we've got the following data: ID equal to 1 and its last modified date equal to 2010. Then we've got row B with last modified date set again to 2010. Then row C 2015. Then again row B, so it is a duplicate that was modified in 2017. Then yet another row B from 2018. Then row A from 2020. And finally row D from 2012. So you can see already those duplicates. So for ID A, we've got two rows, and for row B, we've got 3 rows. And you would like to write a query that will return only the latest, the newest version. And row number will be useful here. But before we start using row number, let's think how it could be solved. So basically, we want to analyze all those rows in groups by ID. And then within each group, I would like to sort my data, my rows, based on a date, and then choose the one with the newest date. So how it could look like? So again, we would have the following data set: ID, date, and something else. So let's group our data within those groups or windows with the same ID. So we will start with rows with ID equal to 1. We've got 2 of them, and let's sort them by a date in a descending order. So the newest version will be on top. So the first one would be from 2020, and actually it would be this row. Then we would have the one from 2010, and that's it about row A, because we have no more rows with identifier equal to A. So then we'll proceed with group B, and here we would have 2018, that's the latest version, the newest one, then 2017 and 2010. And obviously in real life we would have more columns. I'm just using 2 for simplicity. Then we would have a group for row C that has only a single row from 2015, and the same for row D from 2012. And finally, in our result set, we would use this row number function. Row number. And row number simply works in a way that it assigns a number to our results, 1, 2, 3, and so on. And we would like to use it in scope of our groups. And we want to order or enumerate our results based on the way we sorted them by date. So from the newest date as on the top. So in our case, it means that for group A, we would get values like 1 for the first row, because it has the newest date, and then value 2. So that's the first group that was checked. And that's it for group A. Then it will start over from 1 for group B. So it will set 1, 2, and 3 for those values. And then for group C, only 1, and for group D, again, only 1. And now you should see already that actually the rows that we care about, these are the ones that contain 1 as a row number. So it is this row, it is this row, and those from C and D. So simply, it means that in our query, after we apply a row number column, we could set a filter to ignore rows with row number bigger than 1. So it will ignore this, this, and this row. This way, we will leave all those duplicates. And this solution, it will work no matter how many duplicates we'll have. Whether we would have 2 rows for ID equal to A or 1000 rows. It doesn't really matter. It will work no matter what. So basically, in general, Windows functions are super useful, and I use them a lot. So I really advise to read this book by Itzik Ben-Gana. All right, so let's revisit our query. And let's see what can we do here. So actually, we already know what data we have. So let me grab this part. So right now we are still returning all data. We didn't handle duplicates yet, but that's fine. So let's add this row number function. Row number. So basically, it has the following syntax: row number, then over, and we have to provide how it should work. And in our case, we want to partition the data by set number, because that's our key. That's how we want to partition, that's how we want to group our data. So let's do this. So let's add a clause partition by our set number. And then we've got to tell Databricks how we want to order the data within each of those partitions. And I want to order them by date. But please be careful here. We don't want to use this original value, which was treated as a string. No, we want to use a value that was already converted to a date to make sure that the proper comparison will be used. So basically, I will copy this phrase. Let's make sure that it will sort the data descending, so the value on the top, the value with the newest date will be on top. And let's give a name to our column, like rn. And let's run it. And let's see how the data looks like. So we should have this additional column called rn that has values 1, 2, and so on. So for the first minifig, it ordered them by date and assigned these 1 and 2 values. Then for the second minifig, we again have 1 and 2. For the third, we've got 1 and 2 because we have duplicates for those 3 rows. But for remaining ones, we've got only ones. So what we have to do right now is to simply get rid of those values of those rows which have rn different than 1. Simple, right? So you might think, all right, we know that for filtering the data, we can use where clause, where rn is simply bigger than 1, like so. But if you try to execute this, you will come up with this error that at this moment, this rn name is not known. And that's correct. That's how SQL statements are evaluated. It's the order of various things that are a part of our statements. And again, if you don't have a clue what I'm talking about, or if SQL in general is a new thing to you, then again, please revisit these Itzig Ben-Gunn books, but this time read TSQL Fundamentals. It will give you a solid foundation, solid knowledge about SQL. So, very good book. So these two are a must-have for you if you want to be proficient with SQL. Alright, so how to do this? Well, usually, in this case, I just use a common table expression. And I don't want to go deep into what CTE, a common table expression, is. Let me just use it. You can think of it like a named query. So let me create this CTE with, that's how we start to create our CTEs. Then let's give it a name like duplicates s, and then let's provide a query. So that's our query. So simply put, the result of this query will be available as duplicates. So later on, within the same query, I can refer to this duplicates name, like select star from duplicates, where this row number is bigger than 1. And this time it should work. Actually is equal to 1, because I don't want to return duplicates only. No, I want to return the original data, or the data that we decided that should be returned. Alright, and what do we have as a result? Well, for the first minifig, we've got the version with v2. That's fine. For the second one, we've got a version that got this super in the name, which again is correct. And for the third one, we've got a value, the row, that has this endping value in the name, which is correct. So that's how easy it is to handle duplicates. All right, great. But you might say this was an easy task because we have this last modified column. What if we don't have it? What should we do then? And that's a valid comment. So let me grab this statement and let me show you what we can do. So actually this row number is no longer needed. I want to show you how you can get this date in a different way. So basically we've got a function or the method called input file name that if we add it to our query, it will show you a name, in this case a path including a file name from which this particular row was read. Great, but so what? And pay attention now. If you partitioned your data when you were ingesting it by the ingest date, then in this file path you would have year, month, and a date. So you could parse this name, this value, to get a date when this data was ingested. And maybe business will tell you, all right, just use the value that was retrieved as the last. And in this case, this input file name will be very useful. All right, great. And there's one more thing that I would like to cover today, namely nulls. So null, it simply indicates that some value is missing, is unknown. And again, in our data, so in this data set, I have some nulls. So take a look at this image URL column. It has a null for this second version of the row that I added. And maybe, according to our business logic, we don't want to have rows with this that have nulls in this image URL for whatever reason. So we want to get rid of it. So how can we do this? Well, simply you can add a condition to where clause, where something, and image URL is not null, like so. So it will simply eliminate all those rows that had null as image URL. Great. So that's how easy it is to get rid of nulls. All right, but maybe we don't want to remove this row. Maybe we want to keep it and simply replace this null value with something else. Can we do this? Yeah, sure, no problem. We could use a case statement like previously, or we could use call-as function. So here, where we are retrieving this image URL, we could write it as follows. So call-as, then let's provide a name of our column, and then a value that should be used if for particular row this value is set to null, like not available. And let me run this. And this time you can see that this row was not removed from our result set, but simply null was replaced with not available string. So that's how you can handle those null values. All right, so that was it for today. And I hope that you can see now how easy it is to perform various transformations on our data. We started with this JSON file that contained nested structure. It had this array of objects. It had strange column names, wrong data types, but we were able to fix all of those issues. Also, we were able to add some additional columns with conditional logic, this minifig type column, and we were also able to handle duplicates in an elegant way using a window function. row number in our case. And obviously, there is way more transformations that could be done in our data. Today, I just wanted to show you how it could look like. And that's it for today. I hope it was useful, and see you next time. Take care.